All right, in today's lecture, we're going to talk about built-in data types. So these are things in the Java programming language that allows you to store information. We're going to look at the different kinds of common data types we'll be using in the course, how you compare different data types, and we'll also be talking a little bit about generating random numbers in Java. Now, when you have a programming language, you always have some notion of a variable. And a variable is somewhere you store information. And it's information your program needs to do its job. It might be something about how many widgets are in your shopping cart. It might be a certain physical constant in a scientific simulation. It could be anything like that. It could be names of people in a database of a course, things like that. Now, variables always have a unique name. All right, you can name it subject to certain rules. You can name it whatever you like, and it has to be unique. So it's no fair having two variables that have the same name, because then, of course, Java would have no way of knowing which variable you actually intend. And in the Java programming language, each variable also has a specific type. All right, and here's a table with some of the built-in types that are available in Java. These aren't all of them, but these are some of the most useful, and you can actually we'll be mostly using these data types for at least for the first part of the course. First row here is the string data type, and we saw that a bit in the first video when we did the Hello World program. Strings, as you might expect, they store sequences of characters. All right, and so an example might be "Hello World" or "I love this." All right, and notice we've got double quotes. So whenever you have a string, all right, you denote the data carrying part of that variable by putting double quotes and then whatever text you want in between the double quotes. All right, the main operations, what you can actually do with a string variable, you can concatenate. You can take one string and you can add on a little bit more from some other source. Like a string, the char or character data type, it stores characters. Similar to strings, it's kind of like a string with only a length of one. You can only have one character in your char variable. And notice the difference. So you can only have one thing in there, and instead of using the double quotes like in the strings, you use the single quotes. So if you have a variable in Java that's of type char, then you need to use the single apostrophe. The main operation you can do with a char is just compare it. You can see, is this variable equal to the letter A, or is this variable equal to the letter B? The int data type, so int is short for integer, it's good at storing counting numbers. Examples would be like 42 or 1234. It can store positive, it can store negative numbers, so it could store negative 42, it could store 0. All right, but the rule with ints can only store integers, right? So it's no fair including any sort of decimal part. You can't have 42.5 in an int variable. And as you might expect, the operations on integers are things you normally do in math. You can add integers, you can subtract them, you can multiply, you can divide. Excuse me. You can divide and find out what the remainder of the division is. All right, and we'll look a little more closely at divide in a few slides. Another very important data type in Java is the double. All right, double represents a floating point value. So something with a decimal, like 9.95. Maybe you're referring to the price of an item in your shopping cart, or maybe you're referring to the speed of light, 3.0 times 10 to the 8th. All right, you can specify it in scientific notation like this. So you have a decimal, and then this is the exponent of the scientific notation. And as you might expect, operations on those are mathematically related as well. You can add, subtract, multiply, and divide with double values. Rounding it out, at the bottom of the table we have the Boolean. Boolean represents whether something is true or false. All right, you only have two choices. It's kind of like a 0 or 1 or a bit. All right, Boolean variable can be true or it can be false, but It can't be anything else. All right, and the main things you can do with this is do logical operations like logical and, logical or logical not, and we'll look at that in more detail in a few slides as well. Let's have some definitions. So when I'm talking about variables and data types, we're both on the same page. First of all, declaration. All right, in the Java programming language, this first line, int space a semicolon. What this is saying to the Java brains is, I need a variable. I'm going to call it a, and I'm going to store integers in it. All right, you've declared that, and then from that point on, anywhere in your program, you can use this variable a to store things. All right, and the next line is actually does an assignment here. All right, what this line actually says is a is going to get the value 10. All right, we're referring to the variable by its letter a. All right, and what this actually does is copy the value 10 into a. All right, it's not mathematical equals. All right, the right side is the literal value. All right, this is the value 10. So whatever we have on the right side needs to be some sort of integer that can be stored in the variable a. All right, and here's another example. Here's integer variable b. B is getting the value of 7. All right, we could declare a variable c and set it equal to, so we could do the computation a plus b and then copy that result into the variable c. All right, now I don't use animations very often in my PowerPoint, so when I do, you should pay attention. All right, and this is confusing, right? In normal math, equals means equals, right? This does not say, this is not a test to see or a statement of fact that a is equal to 10. This is an assignment. All right, it's copying the value 10 into the variable a. All right, it's perhaps a bit unfortunate, but it's easy to type the equal, and there's no, it might make more sense to have like a little, left pointing arrow instead of the equal sign, but it's kind of hard to type. So keep that straight in your head. Equal does not mean the same thing as equal does in math. All right, when you see equal in the Java programming language, we're talking about assigning the value on the right side of the expression into the left side, into the variable that's on the left. Let's look at each of these data types in more detail. First of them is the string data type. It's just a sequence of characters, 0 or more characters. It could contain no characters, or it could contain hundreds or thousands of characters. All right, you always declare string literals using double quotes. All right, and when you use the plus symbol with the string data type, we're talking about concatenation. All right, not mathematical plus. All right, so in my example here, we see I've declared a string variable called first name, all right, one named last name, and then I'm going to create a new string variable called full name, and I'm going to make that equal to the concatenation of the first name plus a space, so there's actually a little space here, all right, and then concatenate on the last name. All right, I've assigned the favorite number variable. It's also of type string, and I've put the number 42 in there, but it's really the string 42. Because it's in double quotes, it's represented as a string. It's not really an integer, so we can't go computing, taking favorite number divided by 2. All right, it's a string. It's just a sequence of characters, and numbers are characters just like letters are characters. All right, and finally, I'm going to print out the result of concatenating full name plus this little literal string here plus the favorite number, and this is the output if you were to run that program. All right, really the plus operator is the only operator you can use with the string data type. The char data type. All right, not as useful as a string, but there are circumstances we'll be using the char data type in the course. It holds just a single character, so you might imagine, like, for example, in a game, you might get keyboard input from the user, and you might have a variable that holds whatever key they hit the last time, and then decide, should Pac-Man go up or left or whatnot. Use a single apostrophe, not a double quote. If you try and use a double quote, it's not going to work. All right, you got to remember to use a single quote whenever you're using a char data type, you can concatenate using chars, but you have to put them in a string object. So here's an example. I have a char ch1, a char ch2. All right, one's y, one's o. All right, I'm going to put the first character into the string result variable. All right, and there's a little twiddly bit here. This trick, I've got an empty string. This is a double quote and a double quote with no space in between. All right, this is just a trick Java into creating a string for us. This is of type string. This is the concatenate operator for the string data type, and then it can concatenate a character onto the string. All right, and what we're going to get here after this line is result being equal to y. Then I'm going to concatenate on ch2, which is the character o, and I'm going to get 3 O's, and then if I were to print the result out, I'd get yo with 3 O's. The int data type, very useful data type. We'll be using this all the time. It represents an integer, so a counting number could be positive, could be negative, could be 0. All right, and it has a specific range. All right, from very negative big to very positive big. Shouldn't be a problem for most stuff we'll be working with. And here are the operations, all the standard math you might expect, like plus, all right, subtraction. We use the asterisk key for multiplication, right? And we use the / for division. The remainder operator, we use the percent sign. And here's a table with all of these things in play. All right, hopefully everybody knows 10 plus 7 is 17. All right, subtraction, multiplication. Oh, what's going on here? 10 divided by 7. Is the answer to 10 divided by 7 1? It is to Java. All right. This is doing integer division. It's seeing how many times can I fit 7 into 10. Well, it only fits in there 1 with a remainder of 3. This is this line here, 10% 7. All right. If I divide 7 into 10, I get 1 with a remainder of 3. All right. And again, all right, I don't use animations very often. Watch out for this. I cannot stress this enough. You must be very careful with this slash. All right, whenever you use division in Java, what Java does, all right, is it looks to the left, all right, and it looks to the right. And if both sides are of type int, it's going to do integer division, which is not usually what you expect. All right, you might expect this to produce the decimal representing, 10 divided by 7. I don't know, but that's not what's going to occur. The slash always looks to the left and looks to the right and checks. If either side is something besides an int, like a double, then it's okay. But if the left and the right are ints, it's going to do integer division. Watch out for this because it will, I promise you, cause you trouble. All right. You can also cause trouble by dividing by 0. If you take 10, divide by 0, well, you can't divide by 0, and so that will actually cause your program to crash. When we're doing these computations with the integer data type or with the double data type, all right, when we're computing with numbers, the normal rules of mathematical precedence apply. All right, so things you've learned in your math classes, like multiplication and division, come before addition and subtraction. In the first row of the table, I've got 10 plus 7 times 2. It doesn't do it left to right. It doesn't do 10 plus 7 giving 17 times 2. All right, it knows the rules of precedence and knows I should multiply before I add. So 7 times 2 is 14. All right, 14 plus 10 is 24. All right, if I in fact want the 10 plus 7 to go first, I can force that to happen. I need to put parentheses around that expression. Parentheses have higher precedence than multiplication. So the 10 plus 7 occurs first, and then we get the result of 34. All right. Similarly, division gets to go before addition. All right. 10 divided by 7. But remember, 10 divided by 7 is 1. Okay. 1 plus 2 is 3. All right. And here are some other examples showing you can change the result by putting parentheses in there. Floating point numbers. The double data type is an example of something that can store a floating point number. So a floating point just means you can store decimals. All right, and the exact specifics we're not going to talk about so much in this course, but there's actually a IEEE spec, IEEE 754, that defines exactly how this data type is implemented. All right, it's important to understand it's an approximation. All right, it can't represent a non-repeating, non-terminating decimal with exact precision. All right, it's only has a finite amount of memory. It does a pretty good job, and for most purposes we'll need it for, it'll be just fine. All right, and you can do things like add, subtract, multiply, and divide. And once you have the double data type, all right, all these guys, literals on the example column here, are doubles because they have a decimal. All right, even though 1.0, it's maybe it's the same as 1, but because of the 1.0, the 0.0 tells Java we actually mean we're talking about a floating point data type and not an integer data type. All right. Now if we want to get a result like 0.5, all right, if we did 1/2, that would be integer division, but 1.0/2.0 is normal floating point division, which is hopefully is what you probably expect, giving you 0.5. All right, you can divide a number by 0.0, in which case you're going to get a result of infinity. All right, or you can divide 0. If you divide 0 by 0, you get another result called not a number. All right, just so if you see these things, you can actually, this sometimes happens in your program, and so if you see not a number, you'll know that you did something like 0 divided by 0. The Boolean data type. All right, and here's the guy that originally came up with the idea of Boolean true and falseness and logic. Anything declared to be a Boolean in Java is either true or false, and true or false are what's called reserved words in Java. All right, no fair calling. You want to not try. You don't want to call your variables true or false. All right, this particular string means false, so you can assign a Boolean variable equal to false or equal to true, or you can test it against true or false. All right, and this is a very important data type because, as we'll see in future videos, we use Boolean expressions to control the logic and flow of control. So maybe we make a loop or we make an if statement. We'll look at these in future lectures. That's how we make programs do interesting things. All right. The operations you can do on these are logical and, logical or, and logical not. All right. And you've got two ampersands to mean and, two vertical bars for logical or the exclamation mark for logical not. And in the next slide, I'll give you some examples of how this shakes out. All right. If you mean logical and, you should really use two ampersands, and if you mean logical or, use two vertical bars. There's a technical distinction I'm not going to talk about right now, but just use two symbols if you mean logical and or logical or. All right, here's more about the Boolean data type. If you do something like exclamation mark A, what you're asking is A set to false? All right, this actually evaluates to true if A is false. All right, if you say A ampersand B, you're asking are both A and B set to true? Whereas if you ask A vertical bar, logical or, is A true, or is B true, or are they both true? All right. And here's a little truth table. All right. If A is true, not A is false. All right. If A is false, not A is true. All right. Simple enough. It just inverts from true to false and false to true. Here are all the possibilities for A and B. So A could be false, B could be false, A could be false, B could be true, A could be true, B could be false, or they could both be true. All right. These are all four possible settings for two variables that are of type Boolean. A ampersand B, all right, that's wants to see both A and B be true. All right. Are both A and B true? No. Are both A and B true? Well, B is true, but A isn't true, so that's false. Is A true? Yes, but B is false, so that's also false. This guy, logical AND, requires both sides. Whatever's on the left, whatever's on the right, they both have to be true in order for this value to be true. Whereas A logical OR B, all right, vertical bar, if A is false and B is false, well, they're both false. All right, is A true? No. Or is B true? No. All right, so the thing is false. If A is false but B is true, well, that's one side is true, so that's okay. A is true, B is false. Well, one side's true, so that's okay. And pay attention to this one, right? A can be true and B can be true, and this expression is still true, A or B. All right, it's not the case that A or B requires just one of them to be true. They can both be true, and it's still a true expression. One thing you can do to create Boolean expressions, you can take an integer data type and use a comparison and create a Boolean data type. So create something that's true or false. All right. Here are some operators you can use to do that. Equals equals. So remember, when we have the single equals in Java, that means assignment. That's copying a value from the right side into the left side of the expression. 7 equals 7, that's true. All right, 7 equals 8, that's a false statement. Right, 7 is not the same number as 8. If you want to test if two things aren't equal, you use the exclamation mark and then the single equals. All right, 7 not equal to 8, well, that's true. 7 is not the same as 8. That's true. Is 7 not the same as 7? No, 7 is equal to 7, so that's false. All right. You can do comparisons like less than or equal to, greater than or equal to. All right, and here are some examples of true things and false statements using those comparison operators. All right, and you have to do less than and then the equal sign. If you want the greater than or equal to, you've got to do it in this order. If you flip the order, it's not going to work for you. All right. If you want to ask a question, so say you have an integer variable A, an integer variable B, and an integer variable C, you can test to see, well, do the sum of these three numbers, do they sum to 0? You know, maybe that's something interesting your program wants to detect. And here's an expression of how you do that. All right, you put A plus B plus C, and is it equal to 0? All right, be sure to use the equal. All right, Java's pretty good about protecting. If you screw this up, it will probably complain. All right, but other languages may not. So be sure whenever you intend to test equality, use a double equals. That way, there's no confusion about it being a comparison versus being an assignment, like when we use the single equals. Let's say we have an integer variable called grade, and it represents, it's a double variable, let's say, and it represents your current percentage in the course. If you want to see, well, is this current student, are they in the B range, where the B range is greater than or equal to 80% and strictly less than 90%. And here's an expression that does that. We test the grade variable, is it greater than or equal to 80? All right, that has to be true, and the grade has to be less than 90. Because if it was 91, then they're not in the B range, they're in the A range. Here's a somewhat tricky one. Here's shorthand for testing if a number is even. All right, remember that the percent sign is the remainder operator. This divides some items by 2 and then returns a remainder. All right, if you divide a number by 2 and you don't have a remainder, it means the number is even. All right, if you divide this number by 2 and you have a remainder of 1, then it was an odd number. All right. Here's an example program. So this program seeks to determine if a given year, all right, and we'll talk more about what this parseInt is in a few slides, but what it's doing is the user of this program passes in a year on the command line. It then puts that year variable into this variable called year, and then it's going to create it declares a Boolean variable called is leap year, all right, and then it's going to figure out if that particular year is a leap year and then print out true or false. All right, leap years, you may think leap years are, well, is years divisible by 4, all right, but it's more complicated. It has to be divisible. If it's divisible by 4 but not 100, it's a leap year. Okay, except if it's divisible by 400, then it is a leap year. I don't know. Are you confused? I'm confused. All right, but here's how you could do that. All right, this is the first part of that first bullet point. Is it a leap year? Well, first, is the year divisible by 4? All right, and is the year not divisible by 100? All right, if that's true, then according to that statement in the first bullet, then it's a leap year. All right, but we also have to make sure it's not divisible by 400. All right, so if is a leap year or the year is divisible by 400, all right, then it's also a leap year. All right, this handles the case. This adds the case that if we thought it wasn't a leap year, but it turns out it's a year divisible by 400, then it's a leap year again. All right, and you can all these examples. Usually, when I have an example in my lecture slide, you can find a link on the web page, and you can download the example and run it for yourself. Maybe we should pop in. Shall we pop into Eclipse here and run this one? All right, I've got my leap year program here. All right, so same program I just showed you in the slides, and let's go ahead and oops. All right, so as I think I mentioned in one of the videos, if you want to set your run configuration, there's a quirk in Eclipse. You first have to run it. All right, it crashed. Why did it crash? It crashed because I didn't pass in a command line argument. All right, now that I've run it once, I can set the run configuration. All right, I don't know exactly why that is, but that's the way it is. We'll put 2000 in there. Okay, and we can run it. All right, and it comes up as true, whereas if we put in something like 2001 and run it, okay, it's false. We put in 2004. Okay, 2004 is a leap year. All right. And if we wanted to see more about what's going on, all right, we could put in another one. We could put this statement here and see what it is here. All right. So now it'll print out a Boolean here and a Boolean here, and we could set it to something like the year 2000. All right. Notice that initially, all right, is 2000 divisible by 4? Yeah. Okay. But is 2000 divisible by 100? It is. Okay. And this is not equal. All right. And so this resulted in is leap year being false. All right. But it actually should be a leap year because it's divisible by 400. All right. So down here we had is leap year, which was false, or 2000 divided by, what's the remainder of 2000 divided by 400? Well, it's 0, so this is true. All right, one side of the OR is true, therefore is leap year got to set to true, and then we get the correct answer that 2000 should be a leap year. All right, how do you convert between different types? And why do you need to do it? Well, Java is what's called strongly typed. All right, not all languages are this way, but Java is. Everything has a type, and you can't go usually willy-nilly between types. All right, sometimes you have to do explicit type conversion. All right, what Java is trying to do is protect you from making mistakes. All right, and here's an example program. We've got an integer variable called order total, a cost per item. All right, and notice the cost per item is a double variable. It's containing $29.95. And we want to set an order total equal to that times, say, a 6% sales tax, and then print out the total. This will not compile. All right, so here I am trying to compile it on the command line with the javac command. This does not work because what we're trying to do is 29 times, 2995 times 1.06. I don't know what that is off the top of my head, but it's probably not exactly an integer, is it? All right, and you're trying to put this calculation, which has a decimal, into something that can't hold a decimal. All right, and it's complaining about possible loss of precision. All right, it doesn't like putting this double data type into the integer data type. What can you do about it? Well, there are a couple things. You could use what's called a cast. All right, if you really mean this, you can take this thing that is a double value, all right, and force it to be an integer. All right, and when you do this, what you do is you put the data type you want in parentheses, and you put it out front of the expression that calculates the value. All right, but notice what happens here is it just drops the fractional part. It does not round. All right, so if something comes out to be 1.7, if you cast 1.7 to an int, you're going to get 1. It just drops whatever's after the decimal. All right, if you want to round, there's a specific function in Java for that. All right, but a cast like this does not round. It simply drops the decimal point, everything after the decimal point. You can sometimes type conversions between one type and another happen automatically. String concatenation is one example of this. Recall that the plus operator concatenates things onto a string. All right, and in this example, our order total, right, now I've switched around so I don't have this problem. Cost per item is an integer. All right, this integer times this literal is a double, is going to result in a double value, but I've changed the order total to be of type double, and it's okay to put this double into the double, and then I can print it out, and what this printout is doing is concatenating the string total with the double value, and what Java is doing is promoting that double value to be a string so it can live with the total equals part of the expression. All right, and it also converted this cost per item was an integer. All right, but an integer times a double ends up being a double, and that's okay. You can go from integers into double land if you want, but you can't, without an explicit cast, go from double land into integer land. Let's look a little more closely. So we talked last time about the input, so the args array, and the args array always just gets things that are of type string. All right, you've got no choice. You get 0 or more things coming in from the command line, and they're all strings, and they're all strings regardless of what they actually are. So 12 ends up being a string, 0.21 ends up being a string. All right, all these things are strings. All right, and if you want to make this cost calc program, all right, it's pretty difficult. All right, it'd be pretty difficult to compute 12 times 0.21 with two strings. What you really want is an integer and a double in your program so you can do the calculation. Luckily, Java provides a lot of helper methods in its toolkit, and I'm going to show you a couple here that are specifically for this problem of converting strings to doubles and strings to integers. All right, and then I'm also going to show you a helper method that does random number generation. These are what are called static methods, and we'll look at that static methods in detail in a future lecture. But for now, you just need to know you need to use a particular class name. So the math is actually a Java class that comes built in with your Java development kit. All right, and there are static methods in here that can help you do your job, and you can call things like Math.random. All right, integer is another class that comes with the JDK, and there are methods in integer that let you convert, for example, a string to an integer, and double has a static method that lets you convert a string to a double value. All right, and I'll show you in the next slide. When you want to use these functions, All right, these things that convert one thing to another, you use this class name like integer, and then you use a dot, and then the name of the helper method. All right, and here are the two helper methods that you'll need to do type conversion. All right, integer.parseInt. All right, and here's the notation. Here's the name of the method. So that it lives in the class integer. Its method name is parseInt. All right, and notice the case. It starts lowercase, and then the int part is uppercase. Things like this in Java are case sensitive. All right, if you don't capitalize this I, it's not going to work. All right, whenever you call this method, it's like a mathematical function, like sine or square root. You give it some input, and then it produces some output. The input in this case is the string that you want converted to an int. All right, you're going to pass in a string, for example, the second command line argument, args square bracket 1 is of type string. You pass that as the input to parseInt. ParseInt's going to look through that string and figure out how to represent it as a int data type and put it into quantity. Double.parse double does the same job on the third command line argument, converting that floating point value into a double primitive. All right, and we can just put the product. Product is just a string like bananas, and we just copy that one. We can copy straight into product because it's the right data type. We cannot just copy args bracket 1 into quantity. You can't just put a string into an integer variable without using some kind of explicit type conversion in Java, like calling integer.parseInt. All right. And once we do that, we can compute the total of the order straightforwardly, and then we can print out our results. All right, let's look at things that can go wrong. Here are 3 examples of running the cost calc with different command line arguments. So what do you think is going to happen in the first case? We're calculating the cost of apples. There's 6 apples, and they cost -10. All right, and if you look back at this slide, all right, -10, can we convert that string -10 to a double? All right, and you might be worried, well, -10 is really an integer, right? But it turns out that's okay. An integer can be put into the double variable, and there's not really a problem of it being negative. Doubles can be negative, integers can be negative. It's not a problem. All right, does it produce sensible output? I don't know. I mean, 6 apples costs you -$60. All right, maybe this is an ideal program output, but it doesn't actually crash. All right, it will run and produce this output and terminate. Second example, I've changed that the third command line argument to foo. All right, now the program back here is going to try and convert that foo to a double variable. All right, double.parse double is going to try and convert that to a floating point. But what's the floating point value for foo? Okay, it can't do that. If you run this program, you're going to get a runtime error. All right, and it's a runtime error because your program will compile. All right, you won't notice the problem until you try and run it. All right, that's why it's a runtime error. You run it, you get an exception, and then the program terminates. All right, here's the final example. I've changed the quantity to 6.0. All right, and what happens here? Well, this also crashes with the runtime exception. The problem with 6.0 is while it has 0.0, Java is going to think this is a double. All right, it has a decimal point, and so it wants to put that in a double variable, and you're trying to put it into an integer variable, and it's not going to work. All right, in order for this string to be parsable as an integer, it must not include a decimal. All right, so 6 was okay, but 6.0 isn't going to work. It's going to crash. All right, that was runtime errors. Program will compile, but when you run it, you get an error. Here's a program that has a compile time exception. So if you want to see, if you could pause the video if you like and see if you can find the line, and then start the video back up and see if you're correct. All right, You think you found it? All right, it's the sixth line, so 1, 2, 3, 4, 5, 6. It's this line quantity. All right, it's trying to copy the string variable args bracket 1 into an integer variable quantity. That's not allowed. You need to do that integer.parseInt in order for this to work. All right, and there's also an error on line 7 for the same reason. You're trying to copy a string variable into a double. You need to call double.parseDouble. All right, this is a compile time error because Java is smart enough. When you try and compile this with Java C or with the Eclipse IDE, it's not going to work. Java knows enough to know that this is just never going to work. All right. Whereas with the runtime exception, it didn't know until you gave it the bad input. All right. The compiler can't really know, what users users are going to give it for input. But the compiler does know in this code that this could never work, and so that's the distinction. A compile time error, you're never gonna have a chance to run it. All right. Whereas in a runtime error, it will run but will crash depending on its inputs. All right. Let's talk a bit about randomness. What I'm going to show you is an example of simulating the roll of two six-sided dice. So each dice, it can be 1 through 6, and we can sum them together. All right. And what this program needs to do is generate two numbers between 1 and 6. All right. Inclusive of 1 and inclusive of 6. How do we do this? And so randomness is something we're going to use a lot in this course for various games. Randomness is also useful in certain scientific methods, say Monte Carlo methods, and so on. There's a static method in the math class, so that's why we have math dot, and its name is random. All right, it takes no parameters. So normally the functions we have been seeing, you pass something in, like integer, parse int and parse double took a parameter. But some methods in Java don't take any parameters, and random is one of those methods. But you still have to put these empty parentheses, otherwise not going to work. All right. Whenever you call math.random, what you get back is a double, and that double is between 0 and 1.0. All right. And specifically, it's inclusive of 0 and exclusive of 1.0. So here's the mathematical notation for that. I have a closed interval on the left and an open interval on the right. This says I can actually be equal to 0.0, but I can never actually make it to 1.0. I can get really, really close. I could get 0.999999999, but I can never actually get to 1. All right. That's what you get. What we'd like, maybe it would be nice if there was something that say, give me a number, integer between 1 and 6, but there's no such thing. So let's look at how can we build that from this math.random. All right. Well, the first thing is this range is wrong. We're going from 0 to about 1, but we want to go from, 1 to 6. First thing we can do is multiply that number by 6. All right. If we take something that's in the range 0 up to, but not including 1.0, all right, and we times it by 6, we now have a number that could be 0.0, or it could be almost 6. It could be 5.999999. All right. We've got sort of the dynamic range correct now, but we're one off, right? The number should go from 1 to 6, all right, and not from 0. All right. We can add 1 to it. All right, that offsets this. Now we've got a number that's between 1 and almost 7.0 up to 6.999999. All right, and then the final trick is we can cast that to an int. We can just drop this fractional part. All right, and now we've got numbers from 1 up to 6.999, but if we drop, no matter how close we get, we're never going to get to 7. And so now we've got a number that's in the set 1, 2, 3, 4, 5, 6, and they're all equally likely. All right, that's how you generate a random dice roll in Java. All right, and here's the 2 dice program. All right, we've got a variable dice1 that's of type int, a dice2 that's of type int, and here's a calculation I just showed you, math.random times 6 plus 1, and we do that twice, and then we sum them up, and we can print out what the first guy was, what the second guy was, and what the summation was. All right, and don't get confused by this. All right, we've got double quotes. This is not actually a mathematical plus, it's just a string. All right, and that's how I print out the plus in my little output statement. All right, and this isn't actually a comparison or an assignment, it's just a string that contains the equal sign. All right, and we can run that in, we could run that in Eclipse. All right, and these are pseudo-random, but for all intents and purposes, every time we run this, we're going to get something different. All right. Okay. So that's the main content for today's lecture, and at the end here I've got some quizzes. And so what I suggest you do is pause the video and see if you can fill in the resulting type column and the resulting value column. All right, and this first one is on a review of automatic versus manual type conversion. So recall that an int will convert to a double if it's needed to happen, but a double will never convert automatically to an int. All right, and you can cast using this notation with the parentheses and the data type, or you can use a method. All right, so go ahead and pause the video and then jot down on some scratch paper what you think the answers are to this quiz. All right, are you back? Did you really do it? You should really do it. If you haven't done it, pause the video and then fill in the columns. Okay? All right. All right, now you're back. All right, here you go. Here are the answers. The first one, this is a double, right? 3.14159. The int casts it, the resulting data type is an int, and it just cuts off the decimal, resulting in a 3. All right, this was kind of an unfair one because I'd never talked about Math.round. All right, if you were to look this up in the Java documentation, you'd find out that Math.round takes a number and rounds it. All right, and its resulting data type is something called a long, which is like an integer but can be bigger. All right, but hopefully you at least got the answer. For Math.round does what you'd normally expect. If you're converting a decimal to an integer, it rounds to the closest integer. All right, 2 times 3.0, the left side is an integer, the right side is a double. All right, this 2 is going to automatically convert to a double, resulting in a double result and a value of 6.0. All right, this one, we've got a double over here and an integer over here. Okay, but I didn't maybe necessarily mention this, but casts like this have a very high precedence. All right, they get to go first, and so this cast will actually happen before the multiplication. So that 3.0 is going to get cast to an integer data type, and effectively what we have here is 2 times 3, resulting in 6. So hopefully you got the answer 6. But the resulting data type is actually int and not double. All right, this converted to an int, and if you have an int on both sides of the multiplication, it's going to stay in integer land. All right. Again, on this one, the cast goes first, so cast this 2 to an integer, but the 2 was already an integer. All right, this is kissing your cousin. This doesn't really have any effect. All right, if you have an integer times the floating point value, your resulting value is going to still be a double, and you're going to get a resulting value of 6.0. All right, here's another quiz page. This is on string conversion. So recall, whenever you want to convert strings, you want to call integer.parseInt to convert a string to an integer, like int, or parse double if you want to convert a string to a double value. So pause the video and see what you think the answers to these are, what type they are, what the resulting value is, or some of them actually crash, so figure out which ones crash. Okay, here are the answers. First one's an int, no tricks there. 30 as a string, it converts to an int. The resulting data type is int with a value of 30. All right, You can parse double with 30. Okay, that's okay, and it will result in a double, and its value will be 30.0. All right, but no fair trying to convert 30.1 using parse int. 30.1 can't be converted to an integer because it would lose information. That's a runtime error. Can't parse. Parses an int. All right, no problem with this one. 30.1. We're using parse double as appropriate. That converts to a double, and resulting value of 30.1. No fair having other symbols in there. Parse int $30. That's a runtime exception. All right, these things aren't flexible. All right, you can't have extra stuff in here. You can't have a $sign. You can't spell out the word 30 or anything crazy like that. It has to just, if you're trying to parse something that is an int, it better just contain numbers. All right, parse double. All right, this fails because there's no double quotes. All right, 3.14, it's already double. There's no reason to call parse double on something that's already a double. All right, if this was in quotes, this would be okay, but as it is, this is an exception because you can't pass something that's not a string into the parse double. All right, that's its job is convert strings to doubles. All right, here's a tricky one. String concatenation. Recall that plus does addition for numeric types. All right, but if you use plus and it's a string type, we're talking about concatenation. All right, numeric types will convert to a string if they need to. All right, but strings will never go back to being a number unless you call something like parse int or parse double with them. All right, pause the video and try and fill in the resulting type and resulting value. All right, here are the answers. So these are tricky. All right, testing's a string, obviously, right? We've got the numbers 1, 2, and 3, so you might think it might add these things together, but in fact what Java is going to do is go left to right here and just do concatenation. It's going to concatenate the number 1 onto testing, then the number 2 onto testing 1, and then I have testing 1, 2, and then I'll concatenate 3 and I have testing 1, 2, 3. All right. And similarly here, we've got the string 3.1, and then we're adding on this number. It's just going to convert this number to a string and concatenate, creating 3.14159. All right. And as we saw before, in this example, we've got a plus inside of double quotes. That does no kind of math. All right. You can put whatever you want in double quotes. It just results in that string. All right. The space, the plus, and the space are just copied from this string literal right here. All right. And you're actually going to get a string. All these are going to return string data types, and you actually get the string representing 2 plus 3. All right. And then finally, in this example, it's going to left to right, and it's actually going to use numeric addition in the beginning. Right. This is of type int, all right, and this is of type int, so it can go ahead and add those and get 3. This is of type int, and then 3 is of type int, so it can add them to get 6. Then we've got the number 6. All right, now it's trying to add on a string, and so at that point it's forced to go to string concatenation, and then we get 666, and we get the number of the beast. All right. All right, so that's the basics of variables in Java. So important points. So variables are how we store and compute data in a programming language, and we looked at in detail some of the most important data types. So throughout your career as a Java programmer, you'll be making heavy use of the string data type, the int data type, the double data type, the Boolean data type, and probably a lesser degree to the char data type. All right, and Boolean operators, we looked at those like comparison and the logical and, logical or, and logical not. So these are very important as we start building more and more complicated programs, things that have if statements and loops and so on. All right, and the other main topic we talked about today was type conversion. All right, and type conversion is important to understand because, as I say in the last bullet, it's the cause of many software bugs. All right, I'm not kidding. That's why I used many 3 times. All right, it will cause you pain, and so you need to understand what it's doing and the rules Java uses when it does type conversion. All right, so what happens automatically, what you have to force to happen, and so on.